Welcome everyone. The Maxwell-Boltzmann distribution, sometimes referred to as just the Boltzmann distribution, comes up frequently in exams. Exam questions often require students to sketch the Boltzmann distribution. In this video, I'll show you the common mistakes to avoid to ensure that you get maximum marks on questions like this. If you're new to the Boltzmann distribution and collision theory, check out the links in the description to the previous videos. Let's get started. Here's the kind of question that you might get asked in an exam. Complete the sketch below to show a Maxwell-Boltzmann distribution, that is, the distribution of energies of particles in a sample. The line in blue shows a correct representation of a Maxwell-Boltzmann distribution. Zero particles have zero energy, so the graph must start at the origin. The number of particles then rises with energy until a maximum is reached. Then, the number of particles decreases and tends to zero as energy increases. This is also a correct representation of the Maxwell-Boltzmann distribution that I have seen in exams. In the previous example, the number of molecules increased gradually as energy increased. In this example, the number of molecules rises rapidly as energy increases. Let's take a look at our first mistake. In this example, the graph does not start at the origin. Remember, zero particles have zero energy. In exams, it is very important to pay close attention to detail. Diagrams must be large, drawn with a sharp pencil, and clearly annotated. Here's the next mistake. It is not possible to state with certainty what the maximum energy of a particle might be. The line does not touch or cross the x-axis at higher energies. The graph tends to zero as energy increases. Here's the next mistake. The curve is never horizontal. The graph tends to zero as energy increases. Similarly, the curve never rises at higher energies. The curve is never vertical. This is the case both before the most common energy and after the most common energy. The curve never goes back on itself. The curve shown here is incorrect because it goes back on itself after the most common energy. The curve shown here is incorrect because it goes back on itself before the most common energy. Here's another common question. Update the diagram by sketching a distribution of molecular energies for this sample of gas at a higher temperature. At a higher temperature, particles have more energy, so the most common energy lies further to the right. Fewer molecules have the most common energy. The areas beneath both curves are equal. This is because the area beneath the curve represents the total number of molecules. At a higher temperature, there are the same number of molecules. The line in blue correctly represents the distribution of energies of particles or molecules at a higher temperature. This representation is incorrect because the area under the blue line is greater than the area under the original line. This suggests that there are more particles at a higher temperature, which is not the case. The area under the blue line here is smaller than the area under the original line. This suggests that there are fewer molecules present, which is not the case. The most common energy of molecules shown by the blue line is the same as the most common energy of the original line. This is also incorrect. The most common energy is greater at a higher temperature. The higher temperature line shown in blue here is incorrect. It must only cross the original line once. Thanks for watching. I hope you found the video useful. Check out www.flipchem.com. You can email info@flipchem.com for a free user account. On this site you'll find lots of useful quizzes on many different topics. Take care and good luck with your studies.